So today we're going to talk about project two, or your final project for this semester. Here you see the site plan. It's fairly straightforward. You've got a road running up and down the side of the site. You've got a property line running around. Of course, quite a few existing trees. You've got a parking lot running in with a turnaround and parking spaces. And you will be responsible for designing the sidewalks that connect the parking spaces to these townhomes on both sides here. These do not have to be complicated systems. And of course, here we have a series of 8 little townhomes. They're in 4 separate buildings, and they are 2-story. That is, you will have a walk-in side on the front, and 9 feet below that, you'll be able to have a walk-out on the bottom for many of these units as well. So we're going to go through all of these points over here to get you started on this assignment. So we're going to explain a lot of these points as we go along. Of course, in Canvas, you've got a DWG that you can download, basic idea of what you're going to be doing for this site. An important thing you need to realize is there are different combinations of spot elevations for points A and B on this site that each of you are going to use. We're going to explain that in greater detail as we go through these slides. And the other thing to be aware of is that these are the deadlines. Notice that the first deadline is optional. The reason is that we know that you've got quite a bit of work coming up in Studio. So your first interim review deadline is optional. You can get a review that week, that's the week before Thanksgiving, or you can choose not to. The second interim review is required. That is the week after Thanksgiving. You are all required to submit for that second one. And of course, the entire project itself is due a few days after that as well. So as we said, this is the basic site plan. You've got a roadway down the side, a parking lot, and some townhomes that you're going to have to make connections to. Your circulation for this is pretty simple. You're going to have folks that are going to drive in, park their cars, and then they have to be able to walk into these townhouse units. They also will be able to walk out the back of some of these units, perhaps not all of them, but it's important to note that you have a 9-foot difference in elevation between the front of the unit and the back of the unit. And again, we're going to talk about that again in a minute. You also need to make sure that at least 2 of these units are ADA accessible. You might notice in the parking lot that there is a strip of paint that is placed next to a wider parking spot for Americans with disability requirements, so you can create spaces that folks can park to get into the units. You are allowed to move these accessible parking spaces anywhere you wish into this parking lot. You do have to have them, one on this side and one on the other side, and you have to have at least 2 of these units accessible. That is a ramp, no stairs, so that they can be used in accordance with the Americans with Disability Act. And this year, we're going to basically show you how you're going to have to drain this parking lot. This is going to save a lot of time for you as you struggle to get through starting on the concept of this. So it's fairly straightforward. You've got parking lot, it's going to drain away. This is a natural high point in the middle, and that water is going to drain away from the center portion down the parking lots and out into the site. You will, of course, have to drain some water around the buildings. We're going to discourage you from draining water between the buildings, as we discussed in a previous exercise. So now we want to talk just briefly about some of the standards that you have to follow for this assignment. And we're going to go over a few of them because they're a little more detailed than you've had in many of your exercises. And the standards we're going to go over are related just to the structure of the townhouses. That is, how do the townhouses work? How do the finished floor elevations work? How does some of the ADA accessibility work? We're going to talk about these in more detail. So the first standard we want to talk about is the fact that the building units may be stepped down. They may be stepped down in units of 8 inches. The reason is that is the height of a standard concrete masonry unit. So it's important for you to understand that each of these squares represents a building. They may well have two townhouses in each of them, but they each represent one building. That is an important distinction to understand because each of these units represent a separate building. So the red unit could be 8 or 16 inches, or what increment of 8 inches you choose, above or below the blue building. Likewise, the green building could be 8 or 16 inches above or below the orange building. You're not going to change elevations within each of these squares, but you may change elevation between the orange one and the green one, and of course between the blue one and the red one. The next point that we want to bring to your attention is that the change in elevation between the front and the back of the buildings. That is, the back of the building is going to be 9 feet lower than the front of the building. So that means you're going to have about 9 contours stacking on the side of these buildings. And you can add retaining walls as needed. So the foundation walls can be used as retaining walls as well. So you're going to have a 9-foot difference between the back of the building and the front of the building. You also have to have at least 4 of these townhouse units so that you can walk out the back and place some sort of patio in the back. You do not have to have every townhouse unit have a walkout basement, but you have to have at least 4 of them have a walkout basement with a 100 square foot paved patio in the back. And finally, we want to point out that 2 of the entrances for the townhouse must be ADA accessible. That is, there can be no stairs for 2 of these entrances, and the ramps must meet the ADA requirements. Generally speaking, that means you want to keep your ramps at 8% or less. And in the case of this design, there's really no need to go above 5%. Now we want to take a moment to talk about your assigned parking points. That is, each of you will be given a specific elevation for specific locations within the parking lot. Those locations are shown here on this drawing, and they'll also be shown in your AutoCAD drawing. So for these spots in the parking lot, you will each be assigned specific elevations that you have to use, and you'll find that according to your student code. So when you look in AutoCAD, you will see a point A and a point B assigned on the drawing. The elevations that you will use for these 2 points will be unique because each of you will be assigned specific elevations that you are required to use for these 2 points. And again, this will be explained later if you need more help with it. Each of you will have unique elevations that you will use for those specific points in the parking lot. So now we want to talk briefly about where to start. Many of you have done projects, exercises that have some complexity, but where students start always seems to be a bit of a conundrum. So as is usual, we want you to start by understanding the limits provided by the property line, the limits provided by the existing trees, and of course you have some flexibility in terms of where you're allowed to grade at the entry area. But basically this red line is a rough outline of where you should not be grading beyond. So you always need to start by looking at what your limits are on the site. Second thing, of course, you should always be looking at is how does the site drain? In this case, we have a ridge line running along the site, and the site drains off from that ridge line. The difficulty is on this side, it drains towards the buildings. So that's the reason we've already shown you the direction you should drain this parking lot. But understanding where things are going to be draining is always the second part that you want to consider as you're starting an assignment like this. So as you've also learned from previous assignments, once you have those restraints figured out, you always want to start with what's known. And what's known in this case is the elevation where this driveway meets the road. So you will always start from there and work your way up the parking lot. And in this assignment, we've done a large portion of that for you because we've told you what the elevation has to be at A. We've told you what the elevation has to be at B. So you can work your way from the entry point to point A. You can then go up this slope to a high point that's going to exist here that you will determine, and then down this slope to elevation at point B, which we have determined for you. Now, many of you are going to wonder, well, what is the appropriate elevation for this midpoint? And that's something for you to determine. But you know that for a parking lot, the closer you can get to a 2% slope, the easier it's going to be for people to drive on it. You cannot go less than a 2% slope unless you have slope going sideways that will allow it to drain. But you're going to start with a target of trying to get somewhere around a 2% slope, and you know you definitely do not want to go above 5% if you can avoid it. Once you have some numbers in here that seem fair to you, and remember, all you really want is to get these 3 points. You do not want to go into a lot of detail at this point because you always want to work out your concepts as part of the process first. So once you have some elevations figured out here, you're then simply going to go to this curb line. And you're going to say, all right, if I'm going this direction and I go 2%, I can go downhill or I can go uphill, which is preferable for you. Then I've got a curb. At that curb, you're going to go up 6 inches to get to the surface. That is the landscape area. You're not going to worry about designing your sidewalks yet. And then you're going to say, from there, I need to get to the building. And you're still going to target 2% to get to that building. So ideally, you're going to start in the center at some point. You're going to go up or down 2% to get to the curb, jump up 6 inches, and then also use 2% to get to the building. Once you have that figured out in one spot, that same information can be duplicated very easily. So for example, if you found that this was an elevation of say 28, which it could not be on this plan, but that's not the point. If this was an elevation of 28 and this wound up being an elevation at say 30, you could then go and do the same thing by simply adding 2 feet on every one of these. And again, I'm just using that as an example. I'm not saying that is the answer, but my point is, once you do one of these, do not waste your time calculating everyone individually because you are still in the concept phase. So now you've got some understanding of the centerline elevation and then the elevation at the front of the buildings. Now you have to jump down to the back of the building, and that's a 9-foot drop off. So you start with this elevation, you figure out what's a reasonable elevation to get to the building, and then what is a reasonable elevation to get back down to the patio spaces behind where you drop 9 feet. Once you've made that drop, now you need to look at the existing contours and see if your idea works. So if this contour, for example, can stay where it is, that's lovely. If it has to come up a little bit, that's fine. If it has to move down a little bit, that's fine. If it has to move down all the way through this tree, that's a problem. And you're going to find some problems. That's part of the process you're going to go through. You're going to start here, work your way to the building, drop behind the building, and you're going to discover something doesn't work well. And you're going to want to make some changes. So the question is, where can you make those changes? And as we've discussed in previous exercises, you can make a change by changing the elevation here if you wished. You could change the slopes between the parking lot and the building. You, in this case, have the option to add stairs. And that gives you a huge amount of flexibility because if each stair is 6 inches, you add 2 stairs, you'll gain a foot. You do not want to be walking down the stairs into these buildings because then you might have a drainage issue. But you want to come up a couple of stairs in order to correct things in the back, that's perfectly acceptable. Remember, you do have basements on these buildings, but not all of them have to be walkout. You're also allowed to have stairs in the front, but you can't have stairs in all of them because at least 2 of the townhouses have to be ADA accessible. So what you're going to do is you're actually going to play this game where you get an elevation here, work your way from the center to the edge of the parking, work your way from there to the building, jump off the back of the building 9 feet, see how it works. If it doesn't work, you're going to go back and change something. The easiest thing to change is adding stairs. After that, you look at changing the slopes between the building and the parking lot. After that, you look at changing the slopes in the parking lot. You could even add retaining walls if necessary. All of these things are options that you want to play with, and you want to play with these in very rough numbers. That is, you want to work in 1 foot increments if at all possible. Yes, you've got a ½ a foot for the curb here, so that's fine, but you do not want to calculate in detail. You want to work in very rough numbers. Center line to the edge of the parking lot. Hop on top of the curb, distance there to the house, round it out. Come back here, jump down 9 feet, see if it works. If it doesn't work, go back and make a change. The worst thing you can do is to work piece by piece by piece by piece with every calculation, and then you discover it doesn't work, because then you do not want to go back and change it because you put all that work into it. That makes grading an incredibly painful process. So we need you to trust us on this. Work with the rough numbers: center line, edge of parking lot, front of townhouse, jump down the back of the townhouse 9 feet. Does it work? If it doesn't work, go back and change something that's easy until you run out of easy things to change, and then change something that is hard. So this is the basic process for how you're going to solve your concept for Project 2. Once you have a concept that works, even one that works slightly, you want to review it with us before you start doing any of the detailed calculations, and certainly don't start any of the detailed AutoCAD work. Work out your concept first, get us to review it and help you with it, then revise your concept, get us to look at it again if there's time, and then do the detailed work in your calculator and in AutoCAD.